Hi, everybody. Welcome to your Algebra 1, Chapter 1, Section 1 intro. I'm going to actually start by going over how to get to your Clever book in this section. So you can see I am on the Mayfield City Schools webpage. If you just roll over to Students, and if you click on that tab, I'm already there, but if you click on that tab, you'll see Clever pops up. Clever is the hub for most of your books and some of your testing sites. So as soon as you click into Clever, yours will look a little different than mine. If you've never been in it, you'll have to sign in. You can use your Google password. It might ask you for the state and the city. It's pretty straightforward. You can sign in on that. And then when you're in, yours will look a little different than my page, obviously, but you're going to find this icon. It says Big Ideas in Learning. Okay. This is going to be our virtual book. So once you log into there, you won't need Clever anymore. You also won't need the Mayfield website anymore. Now, your screen will look different than mine, but it should be chopped up into 4 sections: top left, top right, bottom right. I believe the top left is your connection to where you want to find your dynamic classroom. That could be your homework area. I'm not sure, but you want to find the dynamic classroom. Now, what this is, this will be our virtual book. You can find the actual book pages when you use the ebook. What the dynamic classroom does is it sets up all of your notes that matches up with the notes packet that we sent you. Okay. So I'm going to be going through this for section 1.1. Now, just in case you need help navigating it, it starts off, it should look like this on the left-hand side, this red tab. This is how you are going to go from chapters to sections through everything. So your chapter 1, and in this, you can drop down. If you want to go through all of these, I suggest you do. Honestly, one of the smartest men in the world, Bill Gates, he did much more than every math teacher ever told him to. He did every math problem in every math book he was ever given. So obviously, we don't have time for that in class, but if you want to be Bill Gates, do every problem in this book. Now, we are going to drop down to section 1.1, solving simple equations. Now, there's a lot of good stuff up here. The explorations I would suggest you do on your own if you want to be the top level student that I'm sure everyone wants to be. We are going to start with objectives and vocabulary. And now we are getting into 1.1, solving equations. Okay. So you can see you're going to have room for all of your vocab. You need to fill all of this in on your notes before you scan and send them in if you want to get full credit for the course. So let's just jump right into what some of these are. Since it's 1.1, a lot of these might seem like review, and that's actually going to be the first one I go over. You see the core vocabulary, then previous. Previous it's not on your sheet, but I'm going to go over what an expression is. All an expression is representing a value of an idea algebraically. So you want to think you're learning a new language, algebraic ease if you want. Really, it's just algebra. But when you write an expression, so let's say, and bear with me because I'm going to be switching to my hover cam a little bit. Let's say you have two. Do I have 2 masks? Let's say you've got 2 markers. Okay, we've got our 2 markers. So that would be just represented by 2m. Now, a lot of you guys already know this, but there's a lot of things here that we need to go over. The number out front that tells me how many markers I'm holding, this is the coefficient. Think co-worker, go together. Co is the number that tells me how many of these I have. This is the unknown. I could be talking about the weight of this marker, the value of this marker, whatever. Right now, let's pretend I'm talking about how much it costs. That would be a value. So in my hand, I am holding a value of 2m. I just expressed it here. Notice there's no equal sign. It's not an equation. Equations have equal signs. Expressions write down what I am trying to say the value of something is using numbers and variables. Algebraic language. Okay? So now let's get into our core vocab. When you have to write down your vocabulary, you can go right to this page and just click on each of these words. It'll take you to the vocab in the book, which is really nice. And if you notice, it opens a new tab. So you'll have to actually X out of this and go back to here. It's not like you have the back arrow, but a conjecture, an unproven statement that is based on observations. If you guys should know your 5 steps in science now, the conjecture is your hypothesis. It is the idea you get from seeing something, okay? We won't use that so much in chapter 1, but it's going to be a good idea. You should know these words. A rule. So a rule is a proven statement about a general mathematic concept, also known as a theorem, okay? So a rule says something is something else. And another big concept that I need you guys to know is means equals in algebraic, okay? If I say something is something else, 5 is 2 plus 3. So is means equals. A lot of you guys know this, and this might be review, but hopefully chapter 1 should be review, I would hope. If it's not, then let's just get to where we need to be and we'll make it review, okay? So let's get back on our page. And then you can go through the rest of all of these. I'm going to hit a couple of them. Actually, I want to talk about almost all these because these are really big concepts. Theorem. Theorem is a statement that can be proven. It's kind of like we already talked about a rule, but a theorem is that step. We had our conjecture. Once we prove it, it's when we can prove it, it's a theorem. If it's an opinion, it can't be a theorem. But a lot of theorems have been proven. So once it's proven, we kind of think of it as a fact. Don't let those things trip you up that much. You'll know the ones that are facts and the ones that aren't. An equation, I already went over equation, is when you set two things equal. It's when two expressions are set equal. Remember, I said, so if I head back to my two markers, okay, before we didn't know what the value of the two markers were, right? So we just called it 2m. But now, what if I said the value of 2m, or I spent $5 on two markers? The value of 2m, or the value of two markers, is 5. And then we're going to teach you, the whole point of this lesson is to teach you to find the value of m. Okay, and that's really going to be the point of algebra in general when we're only working with one variable. Find out what that is. Find the unknown. And now we are at linear equation in one variable. So all we're going to start with is one unknown. That's all it means. Okay, I'm not even going to get into that. Linear equation in one variable, we're only going to be searching for one unknown at a time. That should let you know later on, though, you're going to be searching for two variables and how they interact with each other. Right, and we're going to start off the course, we're going to be searching for value. Later on, we're going to be searching for relationships. So right now, we're just searching for value. A solution is one of the biggest things that you are going to need to understand. A solution to an equation is a value that makes this statement true, 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 okay? And we can look at theirs. X minus 4 equals 2. The solution is 6. Why? Because that's the number that fits in here to make this whole statement true. Now, there will be steps to find out what that value is. But if you know it, if I say you had a choice between 6, 4, and 2, well, if I plug 4 in there, 4 minus 4 is 0. So that does not make the statement true. It is not the solution. Solutions and truth go hand in hand. So we're going to tie a lot of English into our math, but solutions are truth. So if you want to be philosophical in math for a second, we're searching for truth. All right. Inverse operations. You are going to hear a lot of different words for inverse operations. You might hear cancel. You might hear undo. You're going to hear me say undo a lot. Annihilate, cancel. I think I already said a couple of them. So all inverse operations are the things that undo stuff. So when you think of an operation, 4 is a number. That is a constant. That cannot change. M is a variable. It's an unknown. It can vary. That's why it's a variable. We don't know what it is, so we call it a variable. Now, and I guess I probably should have stayed on that one for a second. Let's look at their definition first, and then I'm going to show you what inverse operations are. Two operations that undo each other, such as addition and subtraction. Multiplication and division are inverse operations. When I said 4 and M, so the variable is kind of a noun. It's something, right? It's a value of something. 4 is like an adjective. It tells me how many of those variables I have. So you see how your English skills do matter in math? Well, if we had adjectives and we had nouns, well, now we have our verbs. Our verbs are the operations. So you need to know which operations undo each other. If I add to combine, I subtract to separate. Inverse operations, they undo each other. The opposite of multiplication is division. The opposite of exponents are going to be roots. And that's really as far as you're going to need to know for chapter 1. Even this, we might not get into too much in chapter 1. Actually, we won't get into in chapter 1, I know for a fact. There is one concept I'm going to go over very quickly. I'll save it till later. I apologize. Sometimes inverse, there's another way to do it, and I'll wait till we get to there. So solution inverse, equivalent equations. This is way easier to understand than you think. Equivalent operations are just two things that have to be true. If one is true, I know the other is true. So it's things that'll have the same solution. Now, remember how I said the 2 markers would equal $5? What if I bought 4 markers? I think most of you can do that in your head. Wouldn't 4 markers equal $10? That's not anything crazy to think about. That's obviously true. These are equivalent statements, okay, or equivalent equations. Because in either scenario, does the value of M change? Can't. If 2 markers is 5, 4 markers is 10. So no matter what, and then there's one more equivalent equation, M by itself equals 2.5. The value of a marker is 2.5. Remember, I said a marker, correct? People don't say 1 marker. They say a marker. There's an invisible 1 there. I won't write it 9 times out of 10 because just like if I look at my hand, but go ahead on your own. What do I have in my hand? A marker. Very few people said 1 marker. And if you did, it's probably just trying to mess with me because you know I don't want you to say it. So get used to seeing variables alone. This is how it's going to look typically. We will not write the 1. And this is what we want. This is a solution. It tells me the value of a variable. Now, that will conclude the intro and the vocab. Sorry, I'm hitting buttons, too many buttons. So that concludes the intro and the vocab. And then you can see the rest of the notes for 1-1 as we continue. Thank you very much.